In this lecture, we're going to talk about the midpoint formula. This is probably a good formula to use, or a good lecture to watch after you've definitely talked about the Cartesian coordinate system and plotting points and stuff like that. It also does kind of help, for one of the examples, to have already been introduced to radical notation and root notation in radical and rational exponent equations, although it's not really a necessity for knowing how to use the midpoint formula. So I'll discuss the basic concept of the midpoint formula here, and then some general use of it, as well as some more advanced uses, or a more advanced use of it. The theorem is, for the midpoint formula that is that the midpoint of the line segment connecting x sub 1, y sub 1, and x sub 2, y sub 2 is the point x1 plus x2 over 2, comma, y1 plus y2 over 2. Really what that means is that it is equal to the average of the x values, so I'll say average sub x, and the average of the y values. Because the average is when you add up a couple numbers divided by 2. That's the average of those numbers. Now, I'm going to justify this more than anything else, but I think this is a pretty decent proof as well. So let's suppose that we have a couple points, x1, comma, y1, and another point up here, x2, y2. Okay. And we can find the distance between those points and stuff like that. We can create a right triangle if we want, because really I want to find out what is the coordinates, what is the coordinate of the point directly between those two. Well, like I said, you draw a vertical line from one of the points and a horizontal line from the other point, and you'll create a right triangle. Of course, I didn't have to draw the vertical line that way. I could have drawn the vertical line or the horizontal line this way and the vertical line the other way. But now that I've done this, it's kind of interesting to note that really the midpoint should be about, or it should be exactly, halfway in between, or halfway along this line and halfway along the vertical line. So if you think about it that way, well, then you should easily be able to see that this value is halfway between the two y values, so therefore it is the average of the y values. And this point should be halfway along the x values, so it should be the average of the x values. So therefore this point should have the coordinates, the average value for the x and the average value for the y. That's more of a justification than a proof, but that pretty much brings it around to the proof itself. Really, if you want to be really a huge stickler about the proof itself, you would then say, well, let's compute the distance between these 2 points and the distance between these 2 points and make sure they're exactly the same. And then that would actually prove that that is the midpoint. But I think that's a pretty decent justification. So if you want to find the midpoint between 2 points, just average the points. So let's find the midpoint between a couple points just to try it out. So I'm going to find the x average. Now there's a lot of notations used for the average value of something. I usually use AVG sub whatever letter I'm looking for, so this is the average of x. But a lot of statistics textbooks use an x bar, that means the average of the x. And that's actually mathematically the most common notation. So let's see, the average is just adding up the x values and dividing by 2. Well, this is a complex fraction, so I'm going to multiply top and bottom by the LCD amongst the numerator and denominator, which would be 3. So I'll distribute that 3 through, and I'll get the following: 1 plus 6 over 6, or in other words, 7/6. So 7/6 is the average x value. Let's find the average y value. That's y bar notationally. And again, you add up the y values, which is a negative 1/4 plus 1/3, and you divide by 2. Again, I'm looking for the LCD of both numerator and denominator, which is going to be at 12. So I'll multiply top and bottom by 12. When you do that, you get a negative 3 plus 4 all over 24, or in other words, 1/24. So the midpoint here, which is the average of the x values, comma the average of the y values, is going to be, let's see, 7/6 and 1/24. Not so bad. Even with fractions, not so bad. Now let's do a non-trivial example of this, of the midpoint formula. I had done an example in a previous lecture. The previous lecture was for the distance formula. So if you haven't seen the lecture on distance formula, I highly recommend you watch that first, because we have a person that is sailing, and that person is 3 miles west and 5 miles south of a harbor. So I just said that this right here was the harbor. The person is 3 miles west and 5 miles south. Her name's Leanne, so I called this L. Okay. And then from where from where the harbor is, there is an island that's 8 miles west, so 3 plus another 5 miles west, and 7 miles north. So here's an island out here. And so what we wanted, first thing we wanted to do was find how far this person was, Leanne, from the island. So what I did is I created a right triangle here and used distance formula to find that distance. So that was part A. And like I said, if you want to find that value, or I'm sorry, if you want to actually learn this concept, please go back to that lecture on the distance formula and watch that. But really, I placed on hold part B because I needed the midpoint formula to do part B. So we're going to do part B at this point, right here. So how far will Leanne be from the harbor when she's halfway to the island? It's not until this point that I need to put in a coordinate system. Before, I didn't have to worry about having a coordinate system in here, but now it is very, very important that I have one in here to help me out. So I'm going to put an x-axis and a y-axis. That's my x-axis, here's my y-axis. And I'm going to label some points, like where Leanne is. She's currently at, well, she went back 3 and down 5, so she's at back 3, down 5, -3, -5. The island is back 8, up 7. So the island is at back 8, up 7. Okay. And this question is asking, how far will she be away from the harbor? So what's her distance to this harbor, which I'm going to call the origin, when she's halfway to the island? So I need to find the coordinates, the midpoint coordinate to the island. Now remember, the midpoint is found by averaging the x values and averaging the y values. It's a very complicated question. Midpoint is just the average of the x values, comma, the average of the y values. So let's figure this out here. The x values between Leanne originally and the island are -8 and -3. So we're going to add those two together, -8 plus a -3, and divide by 2. That'll be our average x value. Our average y value, again, you add the y values together, 7 plus a -5. 7 plus a -5. And again, divide by 2. So it looks to me, when you add these up, I get my average x is a -11/2. My average y is 7 plus a -5, which is 2/2. Or in other words, we're at -11/2, comma 1. So let me go back 11/2, which is the same thing as 5.5. So I go back 5.5 and up 1. So let's see if that was a distance of 8. Up 1 might be right here. So this point right there is the halfway, the midpoint between her original location and the island, and that is at a -11/2, comma 1. And really, that's not what the question was asking. It's asking how far will she be from the harbor at this point. So what's her distance from the harbor? See how detailed this question is. Let me erase a little bit of my work here so that I can get room to do some extra work on this page. In fact, I'll even erase the word hold there. And I'm going to draw in a nice little line here that goes from the harbor to the midpoint where Leanne's going to want to know the distance. So just do that here. So we want to know that distance. That's our final distance. So I'm going to call that, since I don't have the letter D here anymore, I'm going to go ahead and call that D. We want to know that distance D. Now again, you should have already watched the lecture on the distance formula at this point. If you haven't, please actually go back and watch it. All right. So here I go. Let me just zoom into that situation, because I'm going to draw a little triangle here, a right triangle that comes down. So I'm going to draw this little right triangle. In fact, I might draw a little bit larger just so I can see it nicely. Okay. And I know the x distance here, the distance from the origin to back to this point right here, is actually a negative 11 halves. It's not, you can't have a negative distance, but you know what I'm saying. Like, that distance right there is positive 11 halves in reality. But the x value is a negative 11 halves. And this distance right here, the vertical distance, is 1. And we're trying to find that. Well, now I can use Pythagorean theorem. Pythagorean theorem says the square of the leg plus the square of the other leg should equal the distance squared. So negative 11 squared, halves squared, plus 1 squared should equal the distance squared. Or in other words, 121 fourths plus 1 should equal the distance squared. Well, 1 is the same thing as 4 fourths, so that's going to be 125 over 4. All right, I got d squared is equal to 125 over 4. Take the square root of both sides, and you'll get that d is equal to the square root of 125 over 4, and you should be able to simplify this actually. 125 is the same thing as the square root of 125. The same thing as the square root of 25 times the square root of 5, and denominator being the square root of 4, that's just 2. This will be 5 root 5 over 2. That's the distance that she is from the harbor at that point. And of course, when you're talking real world situation, you don't want to just yell out, oh, the distance is going to be 5 root 5 over 2. It's much better to actually, calculate it out and tell somebody how far they are away from something. So 5 root 5 divided by 2, that'll give me 5.6 miles roughly. I'll take that out there. So this distance is roughly 5.6 miles. Now again, it's very important to note that this, to be able to really understand this problem, you have to have watched the original video. But it's a very complex problem. This is what I consider to be a concept mastery problem. There's a lot of drawing in this problem. By the way, you could have, for those who did properly watch the distance formula lecture, you could have done this entire problem using points, well, not the entire problem, but this part of the problem, using points instead of using distances like that. Because remember, the distance formula is just equal to the square root of the distance between the x values squared plus the distance between the y values squared. Well, we're trying to find the distance between negative 11 halves comma 1 and 0 comma 0. So let's see. The x value, negative 11 halves, minus the other x value of 0, and the y value of 1 minus the other y value of 0. And you'll see that this actually gets the same computation we just did. This will be the square root of 121 over 4 plus 1 and ... Okay, roughly equals 5.6. So taking something that's a very simple concept, the midpoint, but it can be used in some very advanced applications.